Hi, I'm Leo Porter, and I just wanted to take this opportunity to introduce myself a bit more. I already told you that I'm an assistant teaching professor in the Computer Science and Engineering Department at UC San Diego, but I haven't told you the kind of work that I do. My background is in computer architecture, which is an area of computer science focused on the high-level design of processors. There, my research is aimed at making processors faster, or more power efficient, or both. These days, I spend most of my time doing research on how students learn computer science and how to improve their learning. Most of my work has focused on improving student outcomes through the adoption of an evidence-based teaching practice known as peer instruction. But I've also worked to identify common student misconceptions and to produce meaningful assessments of student learning. In both of these fields, I've used skills from the areas of data science and machine learning to inform and conduct research. Let me give you two examples. One example from computer architecture is we wanted to be able to predict how a program might run on a high-performance computing cluster, given certain architectural features of the cluster. Specifically, we wanted to know if it would be better to run the software using or not using a very specific hardware optimization. To figure this out, we took statistics from a whole bunch of programs and used machine learning to build a model of performance. We could then feed statistics about a single program into the model, and the model would then produce a prediction of how that program might perform on that system. It turned out that our predictions were quite accurate for the problem we were trying to solve. Similarly, in computer science education, we wanted to see if we could use data to predict when students were in jeopardy of failing a course. In many of our classes at UC San Diego, we use clickers like the one you see here. Students answer questions during the term using clickers, and we wondered, could those responses tell us who might be at risk of failing? So what we'd have is a whole term worth of clicker responses per student and how well they did on the final exam. Similar to the architecture example, we just feed that data into a machine learning model designed to predict student outcomes. Then we use clicker data responses from the first few weeks of a new class, feed them into the prediction model, and bingo, we'd see which students were in trouble. Again, the prediction model was quite accurate, enabling instructors to potentially intervene to help students at risk. For this work, and for the prior, I want to reinforce the fact that computer science research is often a highly collaborative effort. And I want to thank my collaborators on these projects. Also, thank you for letting me introduce you to the kind of work that I do.